Alright, welcome to a new chapter on circular functions. So we're gonna look at two exercise, 14a, which is conversion of angles, and 14b with a review of the sine and cos ratios. Shouldn't be a long video. With the conversion, when we measure angles, we have three different types of angles. We have degrees, which is the most common. We're going to use radian, and there's a gradient as well, but we don't use it. So we're focusing on radian and degrees. They are equivalent with different values for uh, different angle. As an example, for 90 degrees, the equivalent of in radian is pi over 2, and pi is a constant. To summarize, to convert, just remember those two conversions. From degrees to radian, you divide your degree angle by 180 and you multiply by pi. If you have an angle in radian, now your angle in radian can be a multiple of pi, but can also be a decimal. You will divide by pi and multiply by 180. If your angle in degrees is a decimal value, your answer will also be a decimal. It doesn't have to be a multiple of pi. Using a cas, here follow it on your in your textbook. You will have the different functionalities how to convert. Also pay attention on your CAS screen on the top right corner. It will indicate to you in what angle you are. So by default, just leave it in radian. But let's say you lend it to your friend changed it to degrees. If you don't pay attention and you calculate some trigonometric ratio and you expect to have the angles in radian and it's set in a different angle, your answer will be incorrect. Okay, so next one, reviewing. In 14b, we're going to review cosine and sine. So do remember you will have a right angle triangle for a given angle. Your sine ratio is your opposite over the hypotenuse. For the cos ratio of that angle, it's your adjacent over the hypotenuse. What we do is we construct a circle of radius 1. So any point P will be gravitating on that circle. What it means is when you from P to the origin, if we draw our right angle triangle, our hypotenuse is equal to 1. Therefore, if you look at the coordinates of that point, the x coordinate is your cosine of theta, and the y coordinate is your sine of theta. The little c indicate that your angle is in radian. If you want to have a degrees, you just change that symbol, to that little bubble, which indicates that you're in a specific unit of angle. Now, because you're on a circle, if you add 2 pi or 360 degrees, you do a full revolution and you come back to the starting point. Hence, if I do cos of a angle plus 2 pi or a multiple of 2 pi or minus, it will be equal to the original cos of theta. So we can simplify the expression here. So we have that's what I explained, that's fine. Okay, now if you have for specific angle values, there are multiple of 90 degrees or pi on 2. So let's look at pi on 2. If your multiple is an odd number, so pi on 2, pi on 2, so odd, so that would be 2k plus 1. So the multiple will be 1, 3, 5, and so on. So it's an odd number. The coordinate of that point is 0, positive, or -1, depending where you are on the circle. So if I do that, what it means is on your circle, you will be up here or down here. As you are on the y-axis, cos is 0, but depending in where, if you have 1, 3, 5, 7, then the y coordinate will be positive or negative. Now if your angle is even, so that's for this one, if your angle is even, let me pick a different color, let's say green. So even is 0 is even, so it's going to be 0, 2, 4, 6. So you start at 0, you go round, that's 2. 2 times pi on 2 is pi, and then you're going back 4, 6, and so on. So here the y coordinate is 0, and the x coordinate will be either 1 here or -1 on this side. So that's for 0, 2, 4, and so on. So it's just a gentle introduction of cos, sine, and sine with specific angle values, and just be really confident with positioning those points at the edge of each quadrant. And that's where we're gonna stop today, and I will see you in the next video. Bye.